Okay, Algebra 2 students, here's a video for example 5 where we're going to use a quadratic regression. Let's listen to this person tell a story about the discus thrower.
Esteban is training for the discus throw. His coach recorded the horizontal distance and height of one of Esteban's discus throws. The points show the horizontal distance the discus traveled in meters and the height of the discus in meters. Use quadratic regression to predict the height of the discus when it has traveled 15 meters from Esteban. The data shows the discus only rising, but when the discus starts to fall to the ground, it will make a shape that looks like a parabola. The model should be a quadratic function. You can use graphing technology to perform quadratic regression with the data. Enter the coordinates of all of the points into the table. Then find the regression features in the calculator's menu. Since a quadratic model is needed, choose quadratic regression. You can write the regression model using the values from the calculator. You take A, B, and C and put them in a quadratic equation. X in your model stands for the horizontal distance of the discus from Esteban. Since you want to predict the height where the horizontal distance is 15 meters, substitute 15 for the horizontal distance in the model. Then simplify. Based on this model, when the discus is 15 meters away from Esteban, it will be at a height of approximately 10.5 meters.
Okay, it wouldn't surprise me if they went too fast through the how to use the calculator on that, especially if you're new. So I am going to try to do it with this try it one. If you think you understood all that, you can give it a shot. I'm going to try to go through it a little slower than they did. So we have all these data points, and we can enter these data points in your graphing calculator. Let's start with a blank screen. So under this button here, Stat, I'm going to edit a list. So it's choice number 1. And this is where they got the list 1 and list 2. So I'm going to put down the times in list 1. So those were 0, and then it was 0.2, 0.4, so on and so forth. So this does take a little time. And then I can arrow over, whoops, enter first. Then I can arrow over to give the corresponding heights. At 0 for a time, it was at 10. This is a different problem than the other one, so it's got a different story. I didn't even read the story, I apologize. 12.24. I just want to get the data in because I know that I need to do the regression. Doesn't really matter what the story is until the end. And 6. You probably should double check all those values to make sure you got them right, because just having one wrong is going to throw it all off. Now we want to do a regression, and we know it's quadratic because it's a fan throwing a souvenir football in the air, so it's going to be a parabola. Anything thrown in the air and affected by gravity is going to have a parabola. So to do that, I go back over to the Stat button, and this time I want to calculate, so I arrow over to calculate, and then I scroll down to quadratic regression, or I can just click 5 and that'll come up. Now it's asking me, do I want are the x values in list number 1? Yes, they are. And if they weren't, I could change that. Are the y values in list number 2? Yes, they are. And I don't really need to do anything else here. I could, if I want. It's kind of a neat feature if you have a graphing calculator that can do this. I can store the regression equation into y equals, which right now I'm forgetting which button that is. Your teacher can show you in class if you give them a heads up. It's a list, maybe it's here. Y bars, function. Yep, that was it. I don't know if you caught all that I did, but this is going to, if I hit enter, it's going to put y1 is going to have this equation automatically stored in it. And now I want it to calculate the quadratic regression. And it's found that A should be negative 16, and B should be 12, and C should be 10. That's my equation. And when I click y equals, you'll see, I hope, that it automatically put it in. Now, it doesn't look like it's there, but it is. 16 x squared. It just has, mine didn't go to integers. Okay, so I have the equation of this souvenir football going in the air. It's the height of the football in feet above the ground for various times in seconds. If the football was not touched by anyone on its way to the ground, about how long did it take the football to reach the ground after it was shown? Well, there's a couple different ways of doing this. I'm going to use a table. I'm going to have the table start at 0, sure, why not? And I'm going to have it change by 1/10 of a second every time. And I'm going to look at the table. You should have already used this function earlier in the course, so hopefully you didn't mind how fast I did that. I'm just going to scroll down until the height comes out to 0. Looks like the height comes out to 0 between 1.2 and 1.3 seconds. So if I wanted to, I could come in here to the table set and start at 1.2 and go up by 0.01 just to be a little more accurate. And it crosses 0 exactly at 1.25. So that's going to be my answer. Let's see what they got. 1.25 seconds. I hope that was enough for you to understand how to use the graphing calculator to do all that work for you. Your teacher can assign some of the following problems: 25 and 30. That's it for this video. Have a great day.